So this is called conditional distribution and density function interval conditioning. Okay, in the previous case, what is that? Point conditioning. So in the interval conditioning, what is the y range? We have to take some range for conditioning event. Okay, so we have already discussed that. What is the conditional distribution function? Here can be written as fx of x by b. Okay, what is b here? B is the conditioning event. Here in the place of b, what is that we told? We will be taking conditional conditioning uh, sorry, we are taking the random variable y, and what is that y value? Y is having some interval. Okay, it is not some specific value. If it is having only one specific value, what is that called? Point conditioning. Okay, now if you have some interval, then it is called what? Interval conditioning. Okay, now what is b here? B will be defined as some interval. Okay, so if you have the distribution function, what is that? Capital F is called distribution function, no? So what is that here? The derivative of distribution function is density function. Now just now we have discussed that. What is y? Y is called conditioning event. Here we are taking some interval for y. Okay, so what is the interval for y? Y will be having the value ya less than capital Y less than or equal to yb. Okay, now if you observe, what is the equation? Okay, so now what is the equation of distribution function? So here the equation of distribution function is given as, okay, fx of ya less than or equal to y less than or equal to b. So from the properties of distribution function, this can be written as the distribution function at x comma yb, the upper limit x comma yb, okay, minus the joint distribution function at x comma ya. Okay, like this we will be defining this. Okay, so we will be defining this joint distribution function at upper limit x comma yb minus fxy of x comma ya. Okay, and what is that we get in the denominator? We get fy of yb, because we will be getting probability of y between ya to ya. Okay, that is ya less than or equal to y less than or equal to yb. Okay, so can you tell me what is that formula we get? So we will be getting probability of capital X less than or equal to small x, okay, intersection probability of ya, that is ya less than or equal to capital Y less than or equal to yb, that will get in the numerator. Okay, yb, and what you get in the denominator? In the denominator we will be getting probability of ya less than or equal to y less than or equal to yb. This is that we are getting in the denominator. Okay, so that is why, how do you write this? This can be written as fxy of x comma yb minus fxy of x comma ya divided by fy, because we have only y. Okay, it is not a joint. Now here it is only the distribution function, so it is fy of yb minus fy of ya. Okay, this we got from the properties. Okay, so from the properties, this can be written like this. Okay, so now we know that what is fxy of x comma yb. So fxy of x comma yb minus fxy of x comma ya. So just now we have discussed, no, what is the y range? Y range is ya to yb. Okay, x range is minus infinity to x, fxy of x comma y dx dy. Okay, similarly, see here what you have to get in the denominator. In the denominator we have to get the marginal distribution function. So the marginal distribution function with respect to y. How do you get marginal distribution function with respect to y? From the density function. So here the x range we have to take it as minus infinity to plus infinity, whereas y range we have to take it as, what is the minimum value is ya to yb fxy of x comma y dx dy. Okay, this is also we got from the properties of density function. Okay, joint density function. Okay, so here this is the conditional distribution function. Conditional distribution function can be written as what is the range of x is minus infinity to x, what is the range of y is ya to yb fxy of x comma y dx dy. Okay, in the denominator what we have marginal distribution function. Marginal distribution function can be obtained from the density function, whereas the x range, what is the x range, we have to take it as minus infinity to plus infinity. Y range we have to take it as what is the y range given in this, so that is ya to yb fxy of x comma y dx dy. Okay, so you'll be having more number of equations. All of you should remember all these equations, then only it is easy. Okay, so now you see here, uh, now what is this is the distribution function. Now what is density function, ma? Density function is derivative of distribution function, no? Density function is derivative of distribution function. Now if you are differentiating this with respect to x, what happens, this integral will be eliminated, so we'll be having the integral only with respect to y. Okay, so what is that, the equation 15 will become, the equation 15 will become, see here, we will be having only integral with respect to y, that is ya to yb fxy of x comma y dy, whereas denominator same thing, integral ya to yb integral minus infinity to plus infinity fxy of x comma y dx dy. Okay, so this equations, equation 15 and 16. What is 15? 15 is called conditional distribution function. Okay, for what, interval conditioning. What is if equation 16? 16 is conditional density function for interval conditioning. Okay, so these two equations holds good for both continuous and discrete, whereas point conditioning we have defined separately for point conditioning we have defined separately for continuous random variable as well as discrete random variable, whereas these two equations are same, holds good for both continuous and discrete random variable. Whereas in discrete case, what is joint density function? So this we have discussed. What is the joint density function in the case of discrete case? So it is summation n is equal to 1 to n, summation m is equal to 1 to m, p of xn comma ym, del of x minus xn, del of y minus ym. Okay, so this is the what is that, this is the joint density function for discrete random variable, so we'll be substituting this for discrete case. Okay, whereas equation 14 15 we have discussed here, no, copy these equations, these two are the equations used to find out conditional density function and distribution function for both continuous and discrete random variable. Okay.